Hi guys, welcome to my course of deep learning. My name is Sahib Singh, as you can see on the screen, and I'm a data scientist and as well as a big data expert. So I have a I have almost 3 to 4 years of experience into data science domain, especially into deep learning and machine learning. And I've been working in companies as well as a technical recruiter, also as a trainer in these domains. Like in this course, we will be focusing mostly on deep learning and whatever uh, I can explain you in depth of deep learning. We'll go and we'll see each and everything like I have did in my machine learning syllabus as well as my big data and Hadoop. All right, so let's go and look at the definition first. And guys, those who have already enrolled with my machine learning or big data courses, they must have a good idea that I am not at all a slide reader, which means only on the introduction video like this one, I only use the slides. Rest, I don't use slide at all. I focus mainly on the practical and as well as to explain the things and the concepts. I take a lot of analogies as well as I give a lot of examples to make you understand a simple logic if you're not getting that. So guys, I'll not simply just read the slide and explain. Of course, in this first introductory lecture, I'll do that. I'll just do explain whatever I will be going to teach you and the introductory part of deep learning. Okay, so let's start. All right. So what exactly is deep learning? Like as per your definition, which is everywhere, deep learning is a subset of machine learning and it is a part of artificial intelligence and which has network capable of learning from unsupervised data which may be structured, unstructured, or unlabeled anything. It has that capability. So we'll see everything in detail. And it is also known as deep learning or deep neural network. So basically, neural networks are nothing but your what is like we come up with the word of neural network from our brain cells, which is your neuron. So that I'll also be teaching you how we come up with that. And so as we go deep into that, so it is named as deep neural network or simply deep learning. After that, what all these are the syllabus which we'll be covering. Like there are many more things that I will be covering, but these are the most important things that should be covered in the course. Like first, this is your lecture for the introduction to deep learning. Then why deep learning, prerequisites, artificial neural networks, convolutional neural networks, Boltzmann machine, it's very important. Autoencoders, not so important, but yeah, you should know. Obviously, we will be working on TensorFlow as well as like in some of the other project in which I have worked on like MNIST. If you know MNIST, like we will be building our own captcha as well as I will show you how to build image recognition in this course itself. Like if you pass an image and it will show you, okay, so this image is like let's say this is image of a dog or this is image of a cat. Everything I'll be teaching you in this course, how to do that and how to make your own model and train it. I'm already having a huge data set to train our model. So I'll obviously show you that. So in those cases, some of the cases we will be obviously using TensorFlow and also we will be going to Keras. Then after that, we will be seeing recurrent neural networks and some of the examples of self-organizing maps. Okay, so guys, I have noted this down. This is like guys, students basically ask me, sir, what is exactly is the difference between deep learning and machine learning? Since deep learning is a subset of machine learning, so is it like machine learning only or so? So like I have simplified the definitions here, which says machine learning uses algorithms to pass data that you know already from a given data. We make informed decisions based on what it has learned. What we do in machine learning, like you have seen so far, we have a we create a model, we pass a training data set, and we get some output, and then we compare that with our testing data set. If you remember, if not, guys, I would highly recommend you to go and take the machine learning or revise the machine learning once again, because for deep learning we will be seeing a lot of machine learning, a lot of statistics, a lot of mathematics, especially mathematics. We will be seeing that. So I would highly recommend to go and revise machine learning at least once. Okay. And deep learning, which what we will be seeing in this course, is a subfield of machine learning. Like I said, it's a subset of machine learning. While both fall under the broad category of artificial intelligence, deep learning is what powers the most human-like artificial intelligence. Guys, I also run a course here which is build your own chatbot. So in that, I have explained you step by step how to build your own chatbot, like not so hi-fi level like your Siri or Cortana or Google Assistant, but a simple chatbot, like those who are very new to this domain, especially new to even Python programming, they can even build a chatbot in an hour. I have explained that. So that's nothing but it's like uh, enabling the most human-like artificial intelligence. That's the example of that. So, okay, so now let's keep aside deep learning for a moment and let me show you something here, which is not a part of this, but you will connect all the dots after some time, like why I am explaining you all this. So, guys, what is this? If you can say, like, this is a very old computer. You can say by 1950s or 1960s, IBM built this computer. You can see there are a lot of keys, functions, and look at the monitor, look at the CPU at the right of it, and even you can see there are a lot of buttons in on the monitor, like next to the monitor. Like these days we hardly have any button, we just have a switch off and switch on button, and that's too, it's getting digitalized, right? So this is a very old computer. Now this is guys, this is you can see this part, this one, this is a 5 MB hard disk in 1956 by IBM. It is, just imagine, this is a 5 MB hard disk which is being transferred in an aircraft. You can see that in this picture, and that too cost 5,000 US dollars. So guys, you can imagine the cost of 5 MB hard disk in 1956. It costs around 5,000 US dollars. All right, so let's move on. And this is your 512 GB hard disk in 2018, like in this year, and it costs around 690 US dollars. So you can just compare with the time, like it's almost, you can say, 70 years pass from this image to this image, almost 70 years, and 5 MB of hard disk is being transferred in an aircraft, and which too costs 5,000 US dollars. And 512 GB, almost, I would say almost 50,000, yeah, almost 50,000 times greater memory it can store, and it's just a small size hard disk, memory card, and it only costs 690 US dollars. So give me a minute. Yeah, so why I'm showing you all these pictures, like why I'm talking about all this, the thing is, when you are working with your machine learning, everything looks great as you are only dealing with your CPUs. Like we are only dealing with the CPUs, like let's say our processors. But when it comes to your deep learning, your computation is going to go a lot more deep, and it is going to increase your computation and all. So your processing time is going to increase, and for doing the same task, it, like this, your CPU might not be sufficient. It will work. I'm not saying it won't work. Your CPUs won't work. Like there are a lot more hi-fi CPUs here, like your Apple recently launched i9 processor. So it's a good CPU. But with i5 processor or i3 processors, it's very difficult. I'm not saying that it won't completely work, but it's getting very difficult these days. So uh, it like basically it will work, but it will be very slow, which usually makes the data scientists who are working on this, or deep learning developers, or anyone who's working with these domains, like especially into data deep learning, they get irritated. Like if it's getting like things are getting slow or delayed just because you're doing everything good and everything is getting delayed. So obviously you'll get irritated, right? You have completed, you just have to sit and wait for long. So to fix this, we use GPUs. GPUs are nothing but your graphical processing units. Let me show you. This is a GPU of NVIDIA GeForce. It is of 8 GB and it costs around 550 US dollars. It's quite costly right now. 550 US dollars is quite costly. And like why I'm showing, why the motive behind showing all these pictures, like this computer, this hard disk, comparing this hard disk to your this hard disk, which is a micro mini hard disk, your you can say pen memory card. So right now what I'm trying to show, in 2018 this GPU is costing you 550 US dollars of 8 GB. Maybe in coming years, let's say 5 years or 10 years, this 550 can be let's say 50 or 100 US dollars. Like that's what I was trying to explain, the connecting the dots. If I want to explain, things will be advanced and technology is increasing and the cost will be reduced gradually. So that's what I was explaining you, those computer and those that picture of memory card. So basically now let's move on to GPUs. So to fix the issue related to CPUs while working on deep learning algorithms, we have introduced graphical processing units, or simply GPU, which is widely used by data scientists and especially gamers. If you are a gamer and you play a lot of high level games, you basically go for a good graphic card, don't you? Like if you are a gamer or if you are a data scientist. So like not everyone is a data scientist, but I believe most of you are gamers. And if you are a gamer, obviously if you buy a computer or a laptop, you'll go for a high graphic card. So this is the use of graphic GPU, or you can say a simple graphic card. So gamers usually buy a machine with high graphic card like NVIDIA GeForce, which is right in front of you. And why they do that is because to reduce the processing time and lags while they're playing. So now you can connect. If any gamer is playing any game, let's say I'm not into games, but I know like there are, let's say GTA, advanced GTA or FIFA, there are many hi-fi games. So if like let's say Need for Speed, so if they're playing that game and when it gets lagged and finally the game is getting game, you can see a game over in front of you. Obviously they'll get irritated just because it's lagging or it's slowing down the processor because there is no GPU. They are simply working on CPUs, or this GPU is very like poor quality. So now you can connect the same thing with your data scientists. Like if they're working with deep learning algorithms and if it gets slow, obviously you'll get irritated. So that is why GPUs are introduced to work on deep learning algorithms to basically to increase the processing time. All right, and GPUs are widely used these days for deep learning algorithms, and I must tell you that companies basically working on deep learning, or let's say AWS also, they usually buy these GPUs, which is a little expensive, and which makes the entire deep learning projects also expensive. You can see like this is 8 GB of GPU, and it is costing you around 550 US dollars. But in a company, they will be using higher GPUs, let's say 16 GB or 2 or 3 of 88 GBs like that. So that will cost companies a lot. So that is why entire deep learning projects, if you have seen any deep learning project, they are also costly. So now you must be getting entire idea how exactly GPUs are and CPUs are. Okay, so let's move on. So let me just complete this, and yeah. So guys, this is uh, Mr. Hilton. You can see Geoffrey Hinton, and he is known as the father of deep learning. You can see his picture right in front of Google headquarters. So he's basically working right now in Google as well, and he's known as the father of deep learning. So he basically invented all the neural network and deep learning concepts, algorithms. There was a time like in 1970s, when he invented deep learning things like I'll not going into deep, but he invented something known as perceptron that we'll see in next lecture. But when he invented that, I have read somewhere that uh, like people were saying that wow, like with the help of this perceptron and deep learning algorithms, they artificial intelligence domain is going to boom in the market at that time, and it did for like 10 years or let's say 8 years. But after that, there was some drawbacks due to which artificial intelligence domain completely degraded. Like it completely removed from the uh, scene at that time just because the algorithms were not strong enough. And why? These days we are having big data. Like we are working on big data. Twitter is generating around 10 terabytes of data per day, each day. So it is very easy these days to train our model, our model. If we want to train it to get high accuracy, we can do that now easily. But at that time, imagine in 1970s, it wasn't easy at all to get a huge data set or big data. So that is why our models were not getting trained well. But this guy, Mr. Hinton, uh, kept like everybody stopped working, and all the companies were like those who are funded, they stopped funding on all the companies, and all the projects were completely stopped. But he continued with his work, and he continued from 1970s or 80s, I don't remember the exact date, till 2006 he worked, and he built some of the other things like you have already seen in your machine learning SVM, right? So he at by 2006 SVM was boom in the market. Only SVM was boom in the market, not the entire machine learning. Like there was no section like machine learning or deep learning by 2006. But SVM, the part SVM was very popular. Only that part was popular at that time. So what happened? There was a Microsoft did one uh, like Microsoft did one project. Like it released a project and said to solve this by creating a model. I'll tell you the project in later videos, but in this I'll just give you a brief. What happened? Microsoft gave one project, and it the project has lots of images. Like in that project, there were two folders. In one folder, there was around 25,000 pictures of only dogs, and in another folder, there were 25,000 pictures of cats. And Microsoft asked, like these days, we can say it's very simple, but at that time, by 2006, it was this was the most difficult, challenging part. So Microsoft asked to build some like algorithm or a model which can differentiate. If we pass any image to it, it can tell, okay, this is a dog or this is a cat. So in total 50,000 images, if we pass any image, built a model that will say, okay, this image is a dog and this image is a cat. So most of the big like Stanfords or Massachusetts, the developers there, they built some models with SVM or classify anything which was popular there, and it was giving accuracy of around it was giving 0.56. Let's say 56% of accuracy was there, or 70% of accuracy was there. So it was very good at that time. But once when Geoffrey Hinton introduced the same thing, the same project, when he did with his deep learning methods and like all the algorithms which he invented, by the span of these 20 to 30 years, when artificial intelligence was completely stopped, the accuracy came to be 93 or 94%, and everybody was very shocked about it to see that. And then from 2006, your artificial intelligence domain again came into the market. So now he is known as the father of deep learning, and all his theories and theses, like basically we are working on that, we are learning that and how to do that. And guys, trust me, he is very good with his research and everything he speaks. Like, if you search on YouTube and about his speech, like if you see his live interactions or interviews, they are worth watching. I have not even missed a single one. Like, there are more than 500 videos on YouTube only on him telling about deep learning on some or the other platform. I follow each and every video of him. It's very like fascinating. So this is like your how your neural network works. So before this, let me draw one example here. Let me show you how exactly it works. So let's say what we were doing so far with machine learning is we had, let's say, one we have like one data set in which this is our age and this is our experience. Remember, guys, I have explained in my machine learning algorithms, like machine learning course, there were two columns of age and experience, and we want to find the average salary which we can predict. And this was our output, and it predicted the salary, right? So this is how we were used to work with your machine learning in your machine learning. But this trend will change in your deep learning. In your deep learning, you will be having uh, many of the inputs. Like, you have one, two, three, four. Let's say to just find the let's say I want to find the price of a house, price of a house or a property. So we are passing not only two parameters, we are passing, like, let's say, what is the age of the house, how old it is, what is the area of the house, and number of, guys, remember, I'm just giving an example here. Bedrooms, number of bathrooms, and let's say there are is the bathroom attached. Let's say these are the things. And now, instead of doing the direct approach, we do a lot of intermediate process in order to reach the final result, the price. So, like, what we do, we pass a lot of algorithms, or you can say functions here. We pass a lot of functions to reach one output. And more the functions we pass in between these, the better is our output. So, let's say I'm not going into deep, but it looks like this. Your each and every parameter will give your output, some or the other output, and this is how it will look like. Guys, just imagine, okay? And finally, it will give some other output. This is how your actual deep learning or the neural network works. This is just a rough network idea, which is not exact thing we will be learning of. Obviously this is just an introductory video. So basically this is how it works. So there will be like there are three layers. Your input layer, like whatever we do the input here is your input layer. This is your input layer, whatever we do the input. This is your output layer, and between this, whatever the functions we are providing is your hidden layers. So basically in a neural network, there are three layers: input layers, output layers, and hidden layers. Again, we will be seeing each and every layer in detail in our entire course. All right. So basically in these layers on which we will be solving our basically your deep learning algorithms. So that's gonna be the main thing which we're gonna focus on. Okay. So let me just close this down, put up my screen. So you can see here, it is very similar to what I have explained. This is your input layer, and in between is your hidden layer, and then finally your output layer. This is how something it looks like. Then I want to show you some real life examples uh, on deep learning. So you can see this object recognition. Uh, like this is how your deep learning recognizes any object. Like if you can see in this picture and you pass a deep learning algorithm or a model to it, it will, if your model is high accurate, like more than 80 or 90%, it will say this is a notebook, this is a glass, or specs, this is your laptop, a coffee, or iPhone. Obviously we have to train each and everything in a training session, but at the final result will look like this. Whatever you pass, it will somewhat look like this. Yeah, amazing, right? And guys, trust me, you will be learning each and everything how to make this in this course. This is very interesting. And this is another example. It's little blurry, but yeah, you can see your deep learning network recognize this is a dog, this is a bicycle, and that's a car behind it. This is how you work on. And another example is your image caption generation. This is the most and widely used these days. And guys, if you know how to do that, you are hired. In any company, you are obviously hired if you can build this. So here you can see if you pass your model, your deep learning algorithm will say a man in black is playing a guitar. Amazing, right? It's just telling you exactly what's happening. Not exactly, but yeah, with 90% accuracy. Construction worker in orange. Safety vest is working on road, right? Two young girls are playing with Lego toy. A girl in pink dress is jumping in air. This is literally, guys, this is real-time examples of deep learning. Black and white dog jumps over a bar. A young girl in pink shirt is swinging on the swing. So this is how your image caption generation works in this. Eh, Everything you're going to learn. You must have seen when you were like submitting any form online and they show you there's a box named click on I'm not a either there will be a captcha to enter some digits. That's also a deep learning concept. Either they'll show you you have to click on I'm not a robot thing, and they'll show you a window will be popped up, and they'll show you there will be some cars or buses on road. You have to select all the buses, and then you have to select all the traffic lights, and this is how indirectly if you do the right thing, obviously they'll pass you, and even indirectly you are training your model again and again. So that's another concept into deep, but I'll teach you that as well. So this is how your if you see your Facebook basically do this face recognition thing. If you have uploaded some of the other picture like of your or any of your friends, it will automatically recognize like it will say like if you click on your face, any face in a group photo which you upload, it will tell you, is this thing this guy? If yes, you can simply click on him and tag. Or it will, if it is not very much accurate, it will show you two or three faces or two or three names whom your model is recognizing, like this face is very similar to these three people of or friend of yours. You select any one of it. So this is how we do, Facebook do, basically. Example, these are, I'm just showing you real-time examples, widely used. You can see deep learning is widely used, right? Also, the same thing, how it does, it do the face alignment and all. Now don't go into deep right now. So this is Sylvester still on face, yeah. So some of the speech recognition, basically into your artificial intelligence, as well as with the help of natural language processing (NLPs). We have some examples like Google Translate, which is a part of deep learning, Siri, Google Assistant, Cortana, Alexa of Amazon. So this is thing. All right, now let's move on to the neuron. Like I said, uh, people started working on brain cells, and they have seen a neural network here. How exactly, like, brain transfers thing from one point to another, and so on. So this is basically a neuron. So we have got the idea of deep learning from this, from neuron. So basically, before going into neuron, I want to tell you that stronger your deep learning algorithms are, stronger will be your output. And how it can be stronger, how the deep learning algorithm can be stronger, by just having a good coding and a huge data set to train it. All right, and all these things will be like image recognition, face recognition, image caption generation, everything I will be in fact teaching you how to develop by your own. All right. And now tell me guys one thing before starting Neuron, I want to tell you one thing. If you meet someone for the very first time, let's say there's a huge probability that you will recognize his face or voice, etc. There's a huge probability, right? If you meet him for the other next time or second time, there's a huge probability. Like, okay, so this is the your brain will recognize. Okay, this is this guy. You met him at this place, or somewhat like this. So basically, this is your human brain, which has all the capability, or you can say a talent, to do that. However, machines can't do that. Like if I give the same task to my machine and tell him like, please recognize this person, so it won't do that, right? Unless until I do provide some deep learning thing, which is now into the market. But before that, it won't do that. The machine will be like, it will be a daunting task for it. So in order to solve this problem, people thought, how about let's simulate the human brain inside the machine itself, so that whatever human can do, at least now machines can try to do. I'm not saying exactly it will do and it can't do, but at least it can, machine can try to do, and that's more than enough. And that's where the concept of neural network comes. Okay, so now if you think, now you can simulate a human brain and try to make your machine as intelligent as your human brain, how interesting it could be. That's what we will be learning in deep learning. Here comes the concept of the neural network, where they studied, like people or the researchers or scientists studied human brain for a long time, and then they figured out how exactly it works, so that they can implement all the features of human brains on machines. So guys, this is a neuron inside your brain, and there are like millions and trillions of neurons. So if I zoom one neuron of a human brain, it will somewhat look like this, right? This is a simple diagram of your human. Those who are good with bio, those who have chosen bio in their school as an additional subject, they must be liking this a lot. So guys, I must tell you, deep learning is for those who are good with maths and good with bio, because bio people will find it very interesting and maths people can handle all the algorithms very easily. So those who are good with both, that's a plus point. So guys, this is like a zoom uh, of one neuron. I have just pulled up one neuron from this and I have just zoomed it. You can imagine like this. So these are your dendrites, and this is your neuron, and this is axon. Neuron is basically your nucleus, and this entire thing is known as neuron. But basically, the point where it is uh, focusing on is basically your nucleus. All right. So basically, your dendrites pass information. What happens in brain, your dendrites have some information and it passes through axon to the other dendrites here, and this is how anything moves on and works in our brain. Like if you touch something, if you touch a hot container or anything, suddenly within fractions of seconds with a lightning speed, your dendrites will pass some weight, or you can say a matter, saying it's hot, it will give you pain. It passed to your brain through axon, and from like each from one dendrite to another dendrite, it is passed through axon, and each and every dendrite is connected to another neuron, and it is somewhat passed like this. So whenever I say neuron, it's nothing but a mathematical function here. It is nothing but a mathematical function here, I want to say, and these are your inputs. Like let's say this is your pain input, it will pain your, let's say hot, it's hot, or this is cold, or this is, if you're tasting something sweet. So everything is going into your neuron, which is saying, okay, this will give you pain, and it will pass the output to the brain as pain. So it is nothing but a mathematical function. Don't go into deep. I'll teach you again neuron part in next lecture. You'll see more beautifully. But this is just for the introduction sake. I'm introducing you things here. So there are a lot of mathematical functions available, a lot of mathematical functions which you will be learning on and working on deep learning. And I'll teach you. And if you go and learn all these things by your own or open sources, you'll find it very difficult. But trust me, I have some techniques or methods. If you are already enrolled with my machine learning or big data and Hadoop course, you will be seeing how, like, I'm not I'm not saying I'm so good with explaining things, but yeah, I try to make things very similar by giving analogies and examples. So this is how you will be this is how, sorry, your neuron will work. If you have some input, this will be your output. So now guys, do you see W here? W, this is nothing but your weight. uh, so remember, let me just show you one example here again. Okay, if you remember your equation here for straight line, let's say y equals to mx plus c, or mx plus c, or let's elaborate, y equals to m1 x1 plus m2 x2 plus m3 x3, and so on. If you remember this, here m1 and m2 are nothing but your weights. These are nothing but your weights that we will be seeing in our entire course. So if I want to give an example, like I'll give you a small analogy here, which I will be giving you in next lecture as well. But to explain things, I want to give you an example here. Let's say we have some hot body here. It is very hot. And when you are a kid, let's say when you are a kid, this is your this is a hot body. I'm just trying to explain things here. And this is how, guys, I usually explain things by giving real-time examples or analogies to understand things and make things easier to learn. Let's say this is a hot body and you are a kid. Let's say you are 2 to 3 years old. 2 to 3 years old. Okay, you're a kid of 2 3 years and you are going to touch a hot body. You don't know, like you are very small, your brain is not developed. So you are going to touch a hot body, and suddenly your parents see it and say, "Hey, don't touch it. You'll feel pain or it is hot. Don't touch it." But since you are a child and we all are very cunning and stupid. You can say stupid when we are so young. So not at that time, but some or the other time we usually want to touch it and see whether my parents are right or wrong. So when my parents say, "Hey, don't touch it," so this is your this is your W weight saying, "Don't touch it. It will feel hot." So you just simply ignore it. Oh, okay. They are simply saying, I'll touch again. I know I am going to touch it. I'm small and stupid. I'll touch it." But when you touch it and you feel the pain, your weight suddenly increases. When you feel it, your weight will increase. Let's say it goes to W2. So this is your how exactly in your neural network your weights work. We will again seeing that in coming videos, but I just want to give an example how your exactly your weight works in your neural networks. All right, so now you have a good understanding of how what is the introduction basic thing about neural networks and how they work. So this is the end of the lesson here, like the introductory video which I want to say. So basically we have seen example of deep learning, a definition of deep learning, what we will be covering here, and I've given you this is the father of deep learning, and some real-time examples and what we will be learning in this course. All right, guys, so this is enough for this introductory video. From next video I won't be using any slide, so hope to see you in my coming lectures. We will be learning each and everything here in coming lectures, and basically because we will be focusing on some basic concepts on how to do what is your perceptron, about the conceptron concept, how exactly your brain works. I'll be teaching you again in deep, and about the input layer, hidden layer, and some of the other activation functions, like most important activation function is ReLU. We will be seeing everything in detail. All right, so let's end the lecture here. Thank you so much, guys. Bye bye.